Friends, in this video we are going to learn about system of equation. So here system of equation is nothing but collection of more than one linear equation. So here you can observe one thing here. This is my equation 1, a11 x1 plus a12 x2 plus radius up to a11 xn. This is equation with n unknown, that is x1 x2 up to xn, and this a11 a12 up to a11 are the coefficient of the unknown x1 up to xn. Now come to here a21 x1 plus a22 x2. This is my equation 2. In this way, this is my mth equation, am1 x1 plus am2 x2 plus radius up to amn xn is equal to bm. So here combine this all m equation. Here this is one equation, this is second equation, this is mth equation. Combine this all m equation in n unknown x1 x2 up to xn. It's called m linear equation in n unknown. That is called system of m linear equation in n unknown. So in the matrix form we can write this system as Ax is equal to B. Here A is my coefficient matrix. Means the first row of my A is corresponding to the first equation of my system. That is, here you can observe one thing, A11, A12, A1n is the first row of my matrix A, that is corresponding to A11, A12, that is up to A11. Now the second row of my coefficient matrix is corresponding to second equation. In this way, the mth row of my matrix, coefficient matrix A, which is equivalent to the mth equation. Here this is A matrix, and here this x1 x2 up to xn is the matrix of unknown, that is we can say variable of order n cross 1. Here this b1 b2 bm is the matrix of constant, that is b1 b2 up to bm. So we can write this system of equation of m equation in n unknown x1 x2 up to xn in the matrix form like this, Ax is equal to B. Here the augmented matrix of this system is here A augmented matrix B. We can write here matrix A and augmented matrix B as here this is simple matrix A and this B is the constant matrix B1 B2 up to Bm. Here based on this B, here if B1 B2, this B1 B2 up to Bm, if B1 B2 up to Bm all are 0, here this is equal sign, then this constant column matrix, that is b1 b2 bm, here if b1 b2 that is up to bm all are 0, then this b is 0. So at the matrix equation, that is ax is equal to b, then the matrix equation ax is equal to b is converted into ax is equal to 0. So here such kind of system is called homogeneous system of equation. And if at least one of the bi, that is here from b1 b2 up to bm, if at least one of this bi, let's say if b1 is non-zero and all b2 b3 up to bm all are 0, then we can say this system is called, this system ax is equal to b is called non-homogeneous system of equation. That is, मेरा कहने का मतलब ये है, अगर एक भी bi इस सिस्टम में, अगर एक भी bi मेरा इस सिस्टम में अगर 0 नहीं है, तो उस पूरे सिस्टम को हम नॉन होमोजेनियस सिस्टम ऑफ इक्वेशन कहते हैं. अगर मेरे पूरे के पूरे राइट साइड ऑफ दिस b1 b2 अप टू bm, अगर ये पूरे के पूरे 0 हो गए तो उस सिस्टम को मैं होमोजेनियस बोलूंगा. अगर एटलीस्ट वन ऑफ द bi इज नॉन जीरो, एक भी मेरा bi 0 नहीं है, तो उस सिस्टम को मैं नॉन होमोजेनियस सिस्टम ऑफ इक्वेशन बोलूंगा. इस सिस्टम को हम मैट्रिक्स फॉर्म में इस तरह लिखते हैं, एंड आर्गुमेंटेड मैट्रिक्स ऑफ दिस सिस्टम इज दिस, एंड हियर दिस इज सेड if all the bi's are 0, that system is called homogeneous system of equation, and if at least one of the bi is non-zero, that system is called non-homogeneous system of equation. Now come to the solution, and solution of system is an equation is an order pair of n tuple x1 x2 up to xn that satisfy all the simultaneous system of equation. Means अगर x1 x2 up to xn, ये अगर जो भी ऑर्डर पेयर मेरा सॉल्यूशन है ये पूरे सिस्टम का, तो ये इक्वेशन 1 को भी सेटिस्फाई करना चाहिए, इक्वेशन 2 को भी सेटिस्फाई करना चाहिए, इन दिस वे इक्वेशन m को भी सेटिस्फाई करना चाहिए. अगर जो भी ऑर्डर पेयर लेट्स से x1 x2 अप टू xn अगर ये मेरे सिस्टम का सॉल्यूशन है, तो इस पूरे इक्वेशन को m इक्वेशन को सेटिस्फाई करना चाहिए, तभी हम इस ऑर्डर पेयर को हमारे सिस्टम का सॉल्यूशन कहते हैं. अगर एक भी इक्वेशन को, ये जो m इक्वेशन है, इसमें से एक भी इक्वेशन को वो सेटिस्फाई नहीं कर रहा है, तो हम जो भी ऑर्डर पेयर ऑफ सॉल्यूशन है इसको हम इस सिस्टम का सॉल्यूशन नहीं बोलेंगे. हियर नाउ consistent system of equation, a system having one or more than one solution is called consistent system, otherwise it is called inconsistent system. इसका मतलब ये होता है कि अगर ये हमारे सॉल्यूशन, अगर हमारे इस सिस्टम को एक सॉल्यूशन है या एक से ज्यादा सॉल्यूशन है तो हम इस सिस्टम को कंसिस्टेंट सिस्टम ऑफ इक्वेशन बोलते हैं। अगर हमारे पास कोई सिस्टम है जिसको एक भी सॉल्यूशन नहीं है तो ऐसे सिस्टम को हम इनकंसिस्टेंट सिस्टम ऑफ इक्वेशन करते हैं। हियर फॉर एग्जांपल, here two equation in two unknown, x plus y is equal to 2, x minus y equal to 2. This is the system of equation having two equation and two unknown. In this equation 1, equation 2, that's mean two equation, and two unknown means x and y are the unknown. Here we can observe one thing, we can add this two, 2x is equal to 4 and x is equal to 2 and y equal to 0 is the, that is x comma y, that is x comma y which is equal to 0 comma 0. ये मेरे सिस्टम का सॉल्यूशन है। That's why इस सिस्टम को हम कंसिस्टेंट सिस्टम ऑफ इक्वेशन बोलते हैं, इसको एक सॉल्यूशन है ये। अगर हम दूसरा एक एग्जांपल लेते हैं कि लेट्स से x plus y equal to 2 and x plus y equal to let's say 4. here ये एक हमारी सिस्टम ऑफ इक्वेशन है, टू इक्वेशन एंड टू अननोन x plus y and here x and y. अगर इस इक्वेशन को मैं इक्वेशन 1 और इक्वेशन 2 में सब्ट्रैक्ट करूंगा तो 0 equal to -2 which is absurd result. So this is here the system is inconsistent because this system has no solution. So अगर मेरी सिस्टम को here, अगर मेरे सिस्टम को सॉल्यूशन है, अगर दिस सिस्टम इज इक्विवेलेंट टू दिस सिस्टम, here अगर मेरे सिस्टम को सॉल्यूशन है तो मैं उस सिस्टम को कंसिस्टेंट सिस्टम ऑफ इक्वेशन कहूंगा। अगर मेरे पास एक सिस्टम है जिसको एक भी सॉल्यूशन नहीं है तो मैं इस सिस्टम को इनकंसिस्टेंट सिस्टम ऑफ इक्वेशन बोलूंगा। Now this is my non-homogeneous system of equation. Here x is equal to b, then b is non-zero, then system of equation this is called non-homogeneous. Here if rank of A is same as rank of A augmented matrix B which is same as n. Here this is my A augmented matrix B whole and this part is my matrix A. If the rank of A is same as rank of A augmented matrix B is same as n, that is n is number of unknowns, means here x1 x2 up to xn are called unknown. अगर मेरे मैट्रिक्स का रैंक ऑफ ए इस सेम एज रैंक ऑफ ए ऑगमेंटेड मैट्रिक्स भी है और व्हिच इज सेम एज n नंबर ऑफ अननोन है तो इस केस में मेरे नॉन होमोजेनियस सिस्टम को यूनिक सॉल्यूशन होता है। एंड इफ द रैंक ऑफ ए इज सेम एज रैंक ऑफ ए ऑगमेंटेड मैट्रिक्स बी व्हिच इज स्ट्रिक्टली लेस देन n, then in this case my system has infinitely many solution. And here if for example here rank is r and n is number of unknown, in this case here n minus r are the three parameters which have to assign for unknown variable, I think x1 x2 up to xn. So we have to assign that three parameter to the variable either x1 x2 or xn. So then in this case my system has infinitely many solution. Now come to the third case, if rank of A is not same as rank of A augmented matrix B, in this case my system has no solution, so here it is called inconsistent system of equation. In these two case my system has, in this first case मेरे सिस्टम को एक सॉल्यूशन है और in this second case मेरे सिस्टम को infinitely many solution है। तो अगर ये सिस्टम, अगर ये दोनों में से एक केस होती है या फिर ये दोनों भी या दोनों में से किसी भी एक केस में मैं मेरे सिस्टम को कंसिस्टेंट सिस्टम ऑफ इक्वेशन कहूंगा। अगर मेरे मैट्रिक्स का रैंक ऑफ ए इज नॉट सेम एज रैंक ऑफ ए ऑगमेंटेड मैट्रिक्स बी है तो मेरे सिस्टम को सॉल्यूशन नहीं होता है। इस केस में मैं मेरे सिस्टम को इनकंसिस्टेंट सिस्टम ऑफ इक्वेशन बोलूंगा, ये नॉन होमोजेनियस के केस में। नाउ कम टू द होमोजेनियस केस, दैट इज x is equal to 0, here b is 0, in b all bi's are 0, that system is homogeneous. Here the first case is the rank of a is same as n, that is number of unknown. In this case my system has unique solution, that unique solution must be trivial or we can say the zero solution. And in second case if rank of a is less than n, अगर मेरे मैट्रिक्स का रैंक that is rank of a is strictly less than n है, that is n is number of unknown, so in this case my system has infinitely many solution. In this case also we have to assign here, for example rank of a which is equal to r and n is number of unknown. So in this case number of three parameter is number of parameter which is equal to n minus r. We have to assign, for example here if we have number of unknown is 3 and rank is 2, we have to, that is n minus 3 minus 2 is 1. In this case we have to assign one parameter as 3, that is let's say t. So this is the thinking.